Okay, here is our question. We've got an amplifier which has got variable frequencies between 100 Hertz, that's the lower limit, and 25,000 Hertz, so that's 25 kilohertz, that's the upper limit. And we've got connected to that a 2.2 microfarad capacitor. Remember, micro is 10 to the negative 6 farad. It's connected to one of the circuits inside the amplifier. Calculate the reactance of the capacitor. Calculate the reactance of the capacitor when the signal is at the lower end of the frequency range. Okay, let's have a look at our equations then. For capacitive reactance, here we go, capacitive reactance, the impedance within the capacitor, the equivalent of resistance in a resistor, is the reactance of the capacitor, and here's our formula here. So let's come back and use our formula. The reactance of the capacitor, XC, is equal to 1 over 2 pi FC, is equal to 1 divided by 2 times pi times the frequency at the lower end of 100 Hertz times the size of the capacitor times 10 to the negative 6. That equals 723 ohms. So two significant figures, so that's going to be 720 ohm. Part 3, calculate the reactance of the capacitor when the signal is at the high end, 25k. So let's see, it's again the same equation. XC is equal to 1 over 2 pi FC is equal to 1 divided by 2 times pi times now 25,000 times 2.2 times 10 to the negative 6. Keep your wits about you when you're using your calculator, and you'll come up with the capacitor, the capacitive reactance of 2.9 ohm. So you can see there's quite an enormous range here between 720 ohms at 100 Hertz, but only 2.9 ohm at 25,000 Hertz, which is kind of what we expect from that equation there. As the frequency increases, the capacitive reactance goes down. I'll get that tongue twister at some point. So that's that question.